In this video, we will be going over polynomial division. Specifically, I'm going to review long division. So I've got a polynomial here, x to the third minus 2x squared minus 29x minus 42, and a known factor of x plus 3. So what I'm going to end up doing is rewriting this polynomial in as a product of three linear factors. Product of linear factors is my goal. And I'm going to use polynomial long division to do that. Okay, so I'm going to have x plus 3 is my divisor. And since it's in standard form without missing any terms, I can write it as is. I don't have to put in any placeholder zeros. Okay, so now we're going to do the process of division, and you're going to, once you get this first step down, remember you're just repeating that same step over and over again. Since we have a known factor here, my end result when I finish dividing should be 0. If I don't get a remainder of 0, meaning no remainder, I've done some of my division wrong. Because this is a known factor, it should divide out evenly. Okay, so I'm going to start with x. And I'm filling in the blank here. So x times what would get me x to the third? And that's going to be x squared, right? Because x times x squared is x to the third. And then I'm going to multiply through. So x squared times 3 would be 3x squared. And notice I'm lining these up so that I can do that subtraction. Most of you like to just change the sign, right? So this would be a minus, and then x squared times 3 would be a positive, so I'm actually going to subtract that here. And then I'm just going to subtract my like terms. So x to the third minus x to the third is going to be 0, which you can write in if you want, you don't have to. And then negative 2x squared minus 3x squared would be negative 5x squared. Now, just like regular long division that you did back a long time ago, you're going to drop down that next term to help you with your next division. So I'm going to drop down that negative 29x. And then I'm going to repeat the exact same process that I just did. So I'm going to do x times some value here needs to get me this term, negative 5x squared, my leading term kind of in this case. So in order to do that, I'm going to say x times negative 5x would get me that negative 5x squared. And then I still have to multiply through to get this next term. So negative 5x times 3 would be that negative 15x, right? And you guys are flipping the sign, right? So I'm really adding here. So negative 5x squared plus 5x squared is 0. Good, we canceled that out, which is exactly what we wanted to do. And then negative 29x plus 15x is actually going to end up giving me negative 14x. And then I'm going to drop down that negative 42. Right, I need to drop down that next term. So I need to think, okay, what multiplies x times what is going to give me that negative 14x? Well, it's going to be negative 14, right? So then, right, I need to multiply through. So negative 14 times x would give me that negative 14x. Negative 14 times 3 is going to give me negative 42. And remember, you're changing the sign because we're really subtracting this off. 0. Negative 42 plus 42 is 0, which is exactly what I wanted. Since x plus 3 is a known factor, I wanted my remainder to be 0. So my new product, right, my rewritten form here of this original polynomial is my known factor times this value here, this new polynomial, right? Because essentially this multiplied by this is equal to my original polynomial. Now, we're almost finished. We actually need to do a little bit of quadratic factoring here because remember, we're trying to get a product of linear factors. I only have one linear factor right now. This is still a quadratic. So I need to rewrite this using those quadratic patterns that we practiced. Right? So what am I going to get here? So what times what is x squared? That's x and x. And then I have to think what multiplies to make negative 14 and adds to make negative 5. And that would be negative 7 and positive 2. And then this is my fully factored form here. That is my product of linear factors representing my original function, f of x.